What is application configuration management on Kubernetes? So let's first talk about a definition for application configuration management. So application configuration could be anything besides the code, right? So anything your application would need in order to run. An example would be configuration for a DNS record your application needs, access to a database or some sort of connection string to a database, for example. Maybe a configuration for a caching mechanism your application would need. Also, like the connection to the cluster it would need to run in, right? So there's a lot of configuration when it comes to external resources your application is depending on. And then on top of that, there's also more application configuration, which I would say is closer to the application or to the code itself, like environment variables, right? So your code might be exposing a couple of configuration settings to environment variables. So you could basically define during runtime, like what configuration your application should use. So these could be like variables, this could be configuration files you might inject during runtime. Also like access to third-party APIs maybe. So the question is now, how do I configure these kind of things inside Kubernetes, right? So Kubernetes has a couple of really nice objects. So besides your pod, which is defining which version of the code is running by defining the container image, for example, there's also objects for environment variables, and this object is called config map, and in there you basically could have a list of environment variables, and those environment variables are then used by the pods. And then same for secrets, for example. Like it's a very similar object, but in this case it's base64 encoded, and is also consumed by the pod, and then the pod has access to those secrets. When it comes to connectivity of your application or of your service to other parts of your application, like other microservices, for example, you might need a service object, which is defining like which route in this pod is accessing which port in this pod, for example. So you ensure the connectivity to other services running in your cluster with this. And then on top, if you need to expose your application to the outside world, you would also need an ingress object. And this ingress object would contain configuration for your DNS record, where it should be accessible and so on. Nonetheless, application configuration management is much bigger than Kubernetes actually. So there's a couple of things which are clearly outside Kubernetes and outside your cluster, and I would still consider them as application configuration, and you also need to somehow manage them. So let's make a couple of examples here. So we already talked about runtime variables stored in those config maps or secrets, for example, in Kubernetes. But on top of that, like when you're building your container, you might also inject build time variables through your CI pipeline, right? So this way you could build like different kind of containers, maybe for development purposes or testing purposes, and they could be different to the container setup you're running in production. So maybe more security in production, more debugging in development, for example. And then on top of that, like anything infrastructure related your application needs to run, you could also control this through application configuration management, right? So there's the term of infrastructure as code, where you use, for example, like Terraform or Ansible to define and set up like a database instance, or maybe you control your DNS records in Route 53 through a Terraform script, or you set up a cluster, or you define like a like the setup of your Kubernetes basically through those scripts. So these could be also dependent on your application, right? So there could be like specific things for your applications, and therefore I would regard this also to some extent as application configuration, which would live in these kind of like scripts and setups. So the one really barebone and down to the root option would be kubectl, right? So with kubectl, it's no problem to maybe update the image version, maybe update an environment variable. It's one CLI to rule them all. essentially, right? So anything which is inside, running inside Kubernetes, so this would be your maybe configuration files mounted as volumes, or maybe your config maps or your secrets, anything you can do with kubectl there. Then the next option I could think of would be running all of this through Helm charts, right? So Helm charts gives you an additional control, basically, when it comes to controlling those configuration settings. So you have basically the option to store your Helm charts maybe in a source code control like GitHub, for example, and then basically apply any changes you do to the Helm charts to the cluster. Helm also gives you the option to roll back basically to previous charts and so on. So you have a little bit more control, and you also have your application configuration management then stored as code as those Helm charts basically would live in your source code control. There's a couple of other tools you could think of. There's an addition to kubectl called Customize, basically, where you have basic options defined in your Customize file, and then by using kubectl you can basically use those things you defined in Customize. And another nice option you could think of, because kubectl is storing everything in YAML files, right? So any definition you're sending to your cluster is basically stored in a YAML file, so you can always store those things yourself as YAML files, and you have all the definitions running in your cluster. And what you could think of is also building some kind of baseline YAML file. And what I mean by this is that you have your baseline of your application defined, and this might work not only for one application, but maybe for many different applications you might be working on. And there could be like a standard database instance, for example, connected, or a standard DNS record could be connected in there, and you don't need to update it. It's part of the baseline YAML, and everything else you would need to update would come as values you then would inject into your baseline YAML. So you could think of this is some kind of container exposing configuration to you, and you could basically inject this into those baseline YAMLs. So I want to show you basically this nice command line phase to talk to the Kubernetes API with a small demo. So I will share my screen here. I'm already connected to a Kubernetes cluster running in Google Cloud, so a GKE cluster. You can basically see this here in my ZSH. And what I'm going to start with, or what you also should start with when talking to the Kubernetes API and trying new things out, is you should create a new namespace. So I'm typing in kubectl create namespace, and then let's call this my demo. So namespace is created, so that's pretty straightforward. Also, what I want to show you really quickly is anything I'm doing here. I'm basically using this nice little kubectl cheat sheet. It's available on kubernetes.io, so all the commands are detailed quite nicely here and also explained on how to use them. All right, so let's continue. So we already have a namespace. So what we want to do now, like a namespace is basically an organizational unit inside your cluster, and inside this namespace, like other Kubernetes objects can live, and they are kind of separated from other objects living in other namespaces. So what we are going to do now is we can basically check, for example, like what do we have running in terms of pods in this namespace. So showing this to you, kubectl get pods in my namespace my demo, and there's no resources found in my demo namespace. So let's fix this really quickly. So for this, I prepared a command kubectl run nginx. So nginx is just a name I'm giving to this pod, and this pod will run the image called in nginx latest. So this comes just from Docker Hub, and it will create this in my demo namespace. So if I now go back to list the pods in my namespace, I now have nginx running there, which is nice. So in order to access this namespace, we can do like kubectl port forward. So the idea here is that nginx is now running in my namespace, and nginx has also a small UI by default. And in order to access this UI, I'm going to port forward into my cluster. So nginx 8080, that's the port it will be having on my local machine, and then I'm going to port 80 on the container basically, which is exposed in nginx. So I'm using namespace my demo, and now I'm forwarding all requests from my local machine to this port inside the container. And I already prepared this, so if I just refresh this page, it basically shows you it goes to localhost 8080 and then shows the welcome page of this nginx container. Alright, so another nice thing you can also do with kubectl is, for example, you can get the pod logs or the container logs basically. So for this we do kubectl logs, and then we want to get them from nginx in the namespace my demo. And you can basically see somebody, and it was me, was just accessing from a Linux machine this pod. So you just see basically that I've been accessing this, and we can just show this again, like doing another access to the pod basically, and then getting the logs, and there is still the same access showing. Okay, fair enough. Yeah, that's because I'm not port forwarding anymore. Anyhow, so we have this pod set up and we can access this logs, but now we basically want to talk a little bit more, like we have now an application running, and we want to be able to configure this application, right? So in order to change, for example, the code which is running inside the container, we would need to update that image. So this is one part of application configuration management, if you want to call it like this. In order to check basically on your pod like what image is running, there's a couple of ways to do this, but one of them would be describe nginx describe actually what object we want to describe. So it's a pod in my namespace my demo. So what you get now here is at the bottom, what's very interesting is a couple of events which happen basically. So when this was created, it was assigned to a resource. So this is basically the node the pod was assigned to. It was pulling the image, nginx latest, and then in the end basically started the container. So these events are actually quite nice to see, and always good to check if you have any troubles with your containers running. And here you can basically see like my pod is consisting of one container. The name of the container is nginx, and it's basically running this image, so nginx latest. So what we can do now, or just want to quickly show you another way of checking on those things, is you can also do like kubectl get pod nginx, and then then namespace, my demo, and then we want to have the output in YAML. So this will look like this. So this is actually showing like the whole pod definition as a YAML file, which is kind of nice because this really gives you like all the information there are, which the Kubernetes API is storing for you for this pod. And here you can also see like under specs, containers, you can basically see the image name, Nginx latest. And it's also possible, like if you don't want to have YAML or want to process this maybe with a different tool, you can also show this information in a JSON format, and then it's pretty much the same. So you basically go to spec containers and then to image. And this JSON format is quite interesting because it gives you nice possibilities to also work with this from maybe other scripts or things you want to write on top. And it also gives us the possibility to, for example, change things in the structure. So I prepared a little bit longer command here for you guys. So this is an example on how you could update the image for this pod. Like there's more ways to do this with kubectl, but this is one thing I want to show. So there's a command kubectl patch, and you're patching the a pod resource called Nginx. And what you're basically applying here is a JSON object, which is exactly talking to specs, containers, and then the name Nginx, and then changing the image from what we had before, Nginx latest, now to a more specific version of Nginx, which is 1.20 Alpine essentially. So I can apply this, and now when I check on this with describe, the most human readable format I guess you could get, and now it basically updated the image to Nginx 1.20 Alpine. So you now what we did now, basically we changed the code of the pod, or the code the container is running essentially, right? So this is one way of doing this. And what you have also seen on top is like Kubernetes understands like JSON or YAML format. And what you can also do, for example, is when you get your pod definition in YAML and pipe it into a file, you can basically store this information. And when it comes to application configuration management, and you might have heard the term GitOps, for example, you can store this information in your code repository. And when you change anything in this YAML file, there's also a command called kubectl replace, and then you can basically reapply or overwrite your pod definition inside your cluster. What is Helm? So Helm is a nice tooling to get your applications running on top of Kubernetes, right? So Helm charts give you the possibility to define every little detail of your application in one place, and then get it running with a nice CLI called basically Helm. I want to do today a deep dive into Helm and into Helm charts and how you can manage application configuration management with Helm. So first of all, let me show you the Helm website. So on helm.sh, you basically find the package manager for Kubernetes, Helm. It's really nicely explained. You can find great details in the docs about Helm. There's a lot of pre-built charts by other people. Everything is open source. They are all served on Artifact Hub, basically. So you can find almost any open source product which is out there and ready for Kubernetes as a Helm chart prepared for you. You can just get the Helm chart and get it running in your own Kubernetes cluster. So this is really, really nice. Yeah. in order to give you some details about Helm, I actually prepared a small demo for you guys. And in this demo, I'll essentially create a namespace inside my Kubernetes cluster. I'll create a demo Helm chart. We'll look at this demo Helm chart, and then we will install this Helm chart into our Kubernetes cluster, see what it's doing, how it's running. We'll connect to it, check the application it spun up, and then we'll also look into the possibilities of application configuration management on top of this Helm chart. So we'll change some values inside this Helm chart and then basically update whatever we changed and see how it's running. All right, let's get into it. So yeah, so you can see now my my terminal basically. So the first thing we basically want to do is using kubectl, we want to create a namespace for ourselves where we can basically experiment and run this demo in. Let's call it Helm demo. All right, namespace is created. Then the next thing we want to do is we want to create a Helm chart. And currently, like if you look into this folder I'm using here, there's nothing there. And basically, I will use Helm, and also just to let you know what version I'm using. Currently, Helm version 3.7.0 is installed for me. I believe this is the latest version currently out there. I will now use Helm to create a new Helm chart, and I'll just call it demo chart. So now it's creating a demo chart. So if I look into this folder, there's a demo chart, but let's look into some of these details, what now has been actually created. Let's switch to Visual Studio Code, and in here basically, so there's a folder demo chart, and inside this folder demo chart there's a couple of components. So there's a folder called charts, there's a folder called templates, a Helm ignore file, chart YAML, and a values YAML. So let's first look at the chart YAML. So here basically you have basic information of the chart, like the version, like the API version it's using of Helm, and then other basic informations. And what's quite nice is like this demo chart, which was created by Helm itself, gives you a lot of information inside those comments. So it's everything is well explained to you, and you can basically then define and alter based on the information you're getting in those comments. Then kind of the centerpiece of a Helm chart is the values.yaml file. And in this values.yaml file is basically all the information you can and maybe want to change in a Helm chart, specifically mentioned basally. So you can, for example, alter the replica count of your application. You can see like this demo is using an Nginx container. Currently the tag is not defined. We'll change this later to also show you like how you can alter and update things. You can specify things like the service account, like pod annotations if you need those for your APM service or something like that. You have a cluster IP as a service defined. You have an ingress defined. Currently, this is just a local ingress or kind of a dummy ingress, but we'll use port forwarding to talk to the application directly. Yeah, you can define other resources. You can define autoscaling for the app, and so on and so on. And this is also very extendable, so you can add your own things basically. And in order to understand like how these values are used, you actually need to look into the templates. And this is really where Helm is different from your usual like Kubernetes YAML files, right? So with Helm, you have suddenly the possibility to define templates. And if you're looking at for example, at this deployment.yaml template, then like in the first moment it looks a little bit overwhelming with lots of like variables and things in there. But if you have a closer look, it looks very, very similar to what Kubernetes is using in their YAML templates, basically. So you have the API version, you have the kind, and you have metadata and so on. And anything which is mentioned here in the in those variables is basically coming from other sections of this Helm chart folder, for example. So if we are looking like if you're looking for something like the image, then this is defined here, right? So like usually you have a specs section, and in the specs sections you have a container sections if you're looking at a deployment YAML for Kubernetes. And then in here basically the image is defined, and the image is actually being pulled from the values file, and then it's basically navigating through this YAML structure to image and repository, and then also the tag is taken from image and tag. So if I now look into the values YAML, basically I can see on top here there's the image section and the repository section. So it will basically take Nginx and then tag. It will not add anything for now. And you can also see, like, as a default, it takes the chart app version basically. So from, let me see, from chart and then the app version. So what this will basically deploy, it will deploy one container with Nginx of the version 1.16.0, right? So this is how this is defined. And then you have basically like lots of templates for the other things, like horizontal pod autoscalers you can define. You can add more things to the ingress service YAML, like for the service and for the service account. But you can also add anything else in here. Like if you want to add, for example, like the creation of a config map, then you just add another YAML file with your config map details. And then if you want to have anything filled in from the values basically into the config map, you can define those by those variables which are basically defined in here. Cool. All right, so like this is a very plain Helm chart demo. So just let's move on and install this to our cluster. So let's see. So this goes with Helm install, and also like what's quite nice is any part of the Helm CLI, it also explains you quite nicely like how certain things are being used, right? So if I just put in Helm install, for example, it tells me like the following arguments are needed for this. So I need to have Helm install, and then I give this a name, and I call this demo chart, and then the name of the chart should be, let me see, demo chart, and then I define the values, and you can basically pass on different value YAMLs basically, right? So for example, you can have one value YAML for your dev environment and one for your staging and one for a production environment, and so on. But currently we only have this one, and then I define the namespace, and the namespace I was creating earlier is basically Helm demo. All right, let's see. Nice. So Helm did a job. Basically it's saying status deployed revision 1, and then it prints out nodes, and you can also I believe you can even alter those nodes based on what you have defined in your Helm chart. So there's also a section for specifically these. But what's quite nice here is basically like it provides you a couple of steps on how to get more information about the pod and about the deployment. So what we can also do is we can just use kubectl ourselves, and then for example get deployment from namespace, and I still have this namespace, and then you basically see like this deployment is up and running. And if we would, for example, also get more details for it in YAML format, you could even see, like in this beautiful YAML structure, that it's now using spec containers, and it's actually using Nginx from the image I was talking earlier about. So this is all nice and clear. So also to show you that things are basically running, let me just walk you through this example. Helm is basically putting out. So it's telling me to export the pod name into one variable, and then, sorry, lots of scrolling involved here, and then the container port it needs, and we echo this so we can basically click on it. And last but not least, we'll do some port forwarding. All right. So now basically what's happening here, we have the pod name, and we're basically getting this from the pods which are running, and it actually is referring to it by its label, right? So Helm is automatically defining a couple of labels for us, and then basically getting from this YAML structure the metadata name, basically, and storing this in the pod name. And then also what it's getting as well is the container port, which is also inside the pod definition, just at another point of the YAML, basically, where it goes into the container ports, and then container port, basically get the container port. And now we are using the kubectl port forward method to be able to talk directly to the pod, basically. So now it's forwarding all traffic from my local host, basically directly to this pod. So if I now go to this URL, let's copy this. We can see an Nginx up and running. Yay! So nothing special there. Cool. Okay. So you now understand like basic usage of Helm. So let me give you another small example, like how can you actually do something like application configuration management. And I will just demo you this on a very small example by just changing the image and then basically updating to my Kubernetes cluster with the new image using Helm. So first of all, like it's using Nginx, so let's just pick another image from Nginx, and I think I'll just go with this one, for example. I hope you can read this. And let's move to the chart again. So usually the only thing you need to touch if you're updating any configuration management should be the values YAML, right? Because everything should be available to you in here, right? So what we are doing now, because we want to have a specific tag, we're basically defining it here, and this will cause the template for the deployment basically to choose from values image tag instead of the default, which was taken from chart app version before, and it will deploy this with a new image. All right, so let's try out this change. So quite straightforward again with Helm. You can use like Helm. Yeah, actually you can almost use the same command as we were using before. So instead of Helm install, you do Helm upgrade, and then it should be all the same. Demo chart, yeah, and to the same namespace. Let's do that. And it's already done. So in order to check that the deployment actually was updated, like we should get a time here, yeah, but we want to see the details of this deployment YAML. So we are just talking to our cluster using kubectl to get the details of the deployment. And here in spec containers, we can now see it's using a different image, still Nginx, but now it's referring to 121.3 Alpine instead of the previous image before, right? So this is how you do application configuration management with Helm. Yeah, so basically, just to sum up very quickly, we have been talking about Helm and how you basically install applications to Kubernetes using Helm. And Helm gives you a nice advantage over your usual like kubectl and your Kubernetes YAML files, because it adds this layer of templating on top, right? So you can now have nice templates and have then all the information you want to change on a regular basis basically mentioned in this values YAML, and this gives you much more control and much more focus on the actual application configuration. So Helm is here a very nice tool and adds a lot of options, and in my opinion makes Kubernetes much more user-friendly. How is it actually possible to build a decent developer experience on top of Helm charts, or how do you bring Helm charts to the next level? So there is a couple of options out there, and we already looked in the last video at Helm in more detail, and also identified like how powerful the templating engine of Helm basically is. So why not use it to build a nice developer experience on top? And there is systems, internal developer platforms like Humanitec, for example, who are using Helm charts internally to basically deliver a nice developer experience and have it really easy to developers to maintain applications. So let's start with something we are calling internally the default module chart, and it's basically our baseline YAML, our baseline chart, where we are able to add anything to it, and it's a very simple one. Let me just show it to you. So here we are looking at the chart, so quite similar structure like we identified in the last video. Basically, you have your chart YAML, you have your values YAML, and you have your templates folder, basically. And this chart in particular is something we use internally for Humanitec to basically deploy workloads for to Kubernetes. And if you look, for example, into the values file, it's one of the shortest values file in a Helm chart I've ever seen, because there's not much in here apart from a couple of structural things, basically. And you can add whatever information into this default module chart if you want to have anything provided basically as a baseline to your Helm charts, to your services, like a connection, for example, to an APM service like Datadog, right? So you're requiring a couple of labels; they should always be existing, and then you could basically add those to this default. And then what's also used are obviously the templates. So we're like supporting like config maps and deployments. There's even a template for any extra objects which might be in this value like YAML ingress secrets, like even for TSL secrets, for example, if you want to have specific DNS added, the service, and so on. So it's quite plain, and it's just powered by those templates. And now in the next step, I basically would like to demo to you how this is actually used inside Humanitec in order to bring your application alive. So for this, I will switch over to Humanitec. So I'm already logged in with my account. I'm using my own like Nils test organization. I already have a couple of demo applications because I'm testing a lot with Humanitec, and now we just want to create a very simple application and deploy it to a Kubernetes cluster I already connected. And this simple application will be just using a BusyBox container. So it's an Alpine based container image I'll be using here just to demo like how this is looking. So in order to do that, we will basically add this default module chart, and you might already see that we have a couple of other kind of Helm charts, or how we call them in Humanitec, workload profiles already available. Like apart from the default module, there's also default cron job, default job, and we have a couple of like in-cluster resources which are using like managed Helm charts in the background. But this is freely extendable by any user of Humanitec, right? So there's basically you can add whatever Helm chart or kind of workload profile you basically have. You can add this to Humanitec yourself and then just deploy it. So by using this, I'll create a workload, and then inside this workload I can add containers basically, and I will just use this BusyBox image. So it's using BusyBox version stable, and I will also add an environment variable, right? So here we basically have a nice UI which makes it possible to us to add whatever information we want to this container. So we have like environment variables, we can map files which will be mounted inside the container, we can add volume mounts, we can change the container configuration, for example, like how much CPU and memory should be assigned. We can set override commands and so on. And then on top of that, Humanitec is also powered by an open source concept around drivers. So you can basically connect any other cloud API you could think of. So for this, we, for example, like what's connected to my account currently, like I have drivers installed for connecting Postgres databases. They will be created in a Cloud SQL account in my Google Cloud basically, and then also a couple of other things. But let's start with this first. So I'm going to add a test variable, like test var and test value, and that's it already in terms of configuration. And then I will just deploy this application. So this is just one application, first deployment. So this is just one simple application, one environment. It only has one service, but as you can see, this is very extendable with more services and so on. So this is actually now being deployed to my Kubernetes cluster. So I already connected my Kubernetes cluster to Humanitec beforehand. And also here in the environment settings, I can basically see what namespace it's creating and where the application will live in. Right, so yeah, so so the application is already running, so let's see how it's looking. kubectl get pods in my namespace. And what we see here's the BusyBox deployment. It's actually in a crash loop, nice, yeah, because I didn't set any command basically. But this doesn't matter for this demo, because what we want to look at is basically how Humanitec is using the Helm chart in the background. So what we can do here is basically with the command Helm list and then the namespace, we can basically list all the Helm deployments which are going to this namespace. And then you can basically see that it's using this default module chart, basically of a very specific version. And what we can do now as well, by using Helm, we can do Helm get values and then BusyBox, and then again the namespace. So what this will do, it will basically give us the new values YAML, which was altered by Humanitec during the deployment process. And you can see here quite nicely, it injected basically all those details. So inside containers, you basically have the image it's using. It's using all those limits, like resource limits and requests, which I could have altered. It has injected like the test variable we set on the UI. And what it's also doing here, it's basically adding a sidecar container for being able to read logs from the container, basically. So those are delivered to the Humanitec platform. Yeah, that's that basically. So I want to also bring this to the next level, essentially, and I want to expand a little bit on this example by adding also adding a database to it. Wait, we don't want to deploy again. We basically want to change this slightly, and what we want to add here on top is basically a Postgres database. So this will basically cause the deployment to add a Postgres database inside my Cloud SQL instance I've connected to Humanitec. And what's quite interesting, for example, you can have those variables like kind of DB name, because the database is not yet created. You basically don't know the database name at this point. So what we can do here is we can use placeholder variables, right? So like this is an external component to my workload. It's called my Postgres, and then I, for example, could put in the DB name, or maybe the DB password, for example, right? So let's do this as well. So these are kind of placeholder variables. All right, so we basically added those two variables. We added a Postgres database. So let's see what Humanitec is doing now under the hood when we deploy this, essentially. Adding a DB. So deployment is running. So what we can already do is we can check on this. So Helm list deployments. So this is already on revision 2. So I'm assuming that this has already been using the new values, and the deployment went through. And now I'm basically checking on the values YAML. And it's definitely a little bit longer. You can still see the image here. And now basically it added secrets, and it added basically the database password, right? So this is auto-generated during deployment time. The database was created in the Cloud SQL instance, and also a user and a database password was created. Here is the name of the database, which was auto-generated, and we also have basically the password, and there would be also any other values available, right? And like if you would be just using Helm, you would you couldn't do this like this, because you can't just dynamically create databases on deployment time and then get those values out, right? So this is basically a nice value Humanitec is adding on top here. In addition, what's also quite nice to see, like there's also like this logging container again, powered by Fluentbit, but in addition, it's also using, let me just check, it's also using a GCE proxy basically to connect to the database, right? So since I'm running in a GCP cluster or a GKE cluster, I can basically connect to the Cloud SQL instance just using this proxy, the sidecar proxy, and this is right away deployed basically with Humanitec, which is quite convenient. All right, that's it already. Thank you very much.